Untitled student, my name is Confident. Welcome again to our revision session of the Mathematics N3 paper, and this is the third lesson. And as I said, this paper was written in November 2011. It's an old paper, but it is worth looking at because some of these questions, as I mentioned earlier, the examiners like to bring them back into the new tests. So you might discover that the exam that you're writing, they usually take from the old question bank, and such papers are very instrumental in assisting you to pass your exam. This is now the full paper here that I'm having, and the instructions, as we say, they are always important for you to read. Now we have looked at question number 1, and if you have not done so, I will encourage you to go through the previous 2 lessons where I looked at question number 1, and we also went on to look at question number 2. So we have also looked at question number 2. Question number 1 was out of 23 marks, and question number 2 was also out of 20 marks. So what I will encourage you guys, I always say, just ensure you subscribe to our channel if you are not yet subscribed, so that you can be able to be notified every time we are posting a new video. You can also switch on that notification bell so that every time there is a new video, YouTube can give you a notification that there is something posted. And also please share this channel with your friends and colleagues so that they can also benefit, and it will be sharing is caring, so you would have actually helped them in a way. Some people are sending us good comments. We really appreciate your comments. If you have got any question or any suggestion, or maybe you find that there is a method that I used and the working is wrong, please feel free to comment below. And if you have got some extra questions that you want me to approach, just tell me, or you can inbox at the comments below, and I'll be able to see them, and one way or the other I will assist you. And give thumbs up to one of the students who has been requesting that I do the whole paper. It's just because you look at different sections. I've got different sections that I'm working on, but this is from a request of a student who said, can you please finish the whole paper, so that we can in a way prepare for our Mathematics N3, which is being written soon. So this is such responses whereby I also look at them, and I know these are my top students that always leave some comments that give me some feedback, and yeah, this is good. So guys, don't forget to keep on sending me your feedback. The more you give us feedback, the better it is at me knowing that you guys are really benefiting from the channel. So now let us look at question number 3 in this section. We're looking at question 3. I'll try to stretch it as much as I can depending on time. Maybe I'll look at 3 and 4, but let's look at this question 3 for now. It says sketch the graphs of the following equations in the answer book. So you're using the answer book. There is no graph paper in N3, so remember that. So you have to sketch it in your answer book. It says each graph must be drawn on its own system of axes. Label the graphs fully and name the type of graph below each sketch. So now the first one is, you are supposed to sketch 400 is equal to 16y squared plus 25 x squared. So if I can come and have my page here. Now remember guys, as I said, you don't have a graph paper, so what usually you have is a line like that. That's what usually you have in your normal answer book. So but the question here, if I can use the same, says 400 is equal to 16y squared. So if I can have that, it's 400 is equal to 16y squared and plus 25x squared. All right, so this is what you need to sketch. So now if I take 400 to the other side, what I have is, and then I interchange this, so I will have 16 starting with yeah, it's fine even if I start with y. 16y squared plus 25x squared. Actually this is fine as is. What I need to do here is simple to interchange that. If I interchange this, what I have is 16y squared as is plus 25x squared is equal to 400. Already this is arranged in the general form. Remember, the general form is in this way. It is if I'm to write it, it's a squared x squared plus b squared y squared is equal to 1. So that is the general form in a way when you're dealing with your ellipse. So this is the equation of an ellipse. So what you simply need to do here, you need to, sorry about that, I must divide, actually it's over a squared here. This is the general equation of an ellipse. It's x squared over a squared plus y squared over b squared is equal to 1. So this is the general equation of an ellipse. So now what I need to do, first things first, is to divide my equation 400. You see it says is equal to 1. So I have to divide by 1. Even on the other side, so it's 25, by 400 to make it a 1. So it's 25x squared. So I've got 25x squared over 400, and then I have 16y squared over 400. So it doesn't matter the x and the y arrangement, but at the end of the day, remember the key part is to ensure that the right hand side is equal to 1. That is very key. So when you divide 25 over 400, in this case, if I divide 400 divided by 25, or I think it's a 16, or I say 25 over 400, I'll get 1 over 16. So you can see that. And what about 16 over 400? So if I say 16 over 400, I get 1 over 25. So what I have here is y squared over 25 plus x squared over 16 is equal to 1. Now if you continue working on this, remember now it's a x squared over a squared, or y squared over b squared. So you can see that this is y squared, 25 is same as 5 squared plus x squared over 4 squared is equal to 1. Then you need to sketch now this part. Now when you are sketching this diagram, as they said, you need to use in this case they said use sketch on your answer book. So what you have, this is what you'll be having as your answer book. So you have here your y, you have here your x, and then when you are sketching, you look at the numbers. You see you have got 5 on the y-axis, and then you have got 4 on the x-axis. So on the y-axis you have 5, so you can name this as 2, 4, 6. So if I can have 2, 4, 6, so the center there will be my 5. And then also on the x-axis I have got 2, 4, 6, that is the negative 1. And then even here it's 2, 4, 6, the negative 1. Then in here I've got minus 5, and again here is 2, 4, 6. So I've got 2, 4, 6. So this is what I'm having. So if I'm to sketch this, this is an ellipse, remember. So the way I'm going to draw it, so I have a point there, 5, and a point in minus 5. So my points are plus or minus 5. That is y is equal to plus or minus 5, and x is equal to that 4. It means it is plus or minus 4. So you have got a minus 4, you have got a plus 4. Now guys, I'm just doing this because remember there is already lessons that I've done in my mathematics N3 for the underdogs. So that's what I'm using here. If you haven't gotten a hold of it, you can also grab the book. It can be of benefit to you. It comes already with videos so that you can use those videos. It's a full curriculum of N3. You use the videos with the book. It's very, very effective. So now when I'm sketching this particular part, it's an ellipse, as we say. So you'll be having, obviously you can sketch something much better on your side. It's not really something a good diagram from what I'm seeing, but this, as if I try to, like that, this is not bad, but the aim is that the shape is oval. It's supposed to get like an oval shape, but anyway, this is what they're expecting. You are writing then the equation itself to say in here it was 16y squared plus 25x squared. It's 400 is equal to, so that is the equation that you're plotting in this case. So that's what they wanted you to. If you look at the question, which says sketch the graphs of the following equation in the answer book, then say each graph must be drawn on a system of axes, label the graphs fully and name the type of the graph below each sketch. Now to name it below its sketch, so we are supposed to say here below the sketch, this is an ellipse. Okay, so that will give you your 3 marks. The next graph is xy is equal to minus 8. So we're looking at question 3.1.2. It's xy is equal to minus 8. This is also 3 marks. So if I can do it again, so what I have is the graph of xy is equal to minus 8. So now if I can make y the subject of the formula, you divide by x. So xy over x is equal to minus 8 over x. So when I do that, I've got my graph of y is equal to minus 8 over x. And this type of a graph is a hyperbola. So with a hyperbola, we can actually, this is just a sketch. You don't need to be more accurate in this case. If you still remember in the hyperbola, maybe just to say, if I have got my plane like this, my Cartesian plane, this is my y and my x, and also my y and my x, just to remind you. Now a hyperbola is, you sketch it in 2 areas. You have got one in the 2 quadrants, so this one is in quadrant number 2 and quadrant number 4, and the other one is in quadrant number 1 and quadrant number 3. Now if it's in quadrant number 1 and number 3, your graph will be y is equal to a over x, right? And if it's in quadrant number 2 and 4, it's y is equal to minus a over x. So if it's negative, that's where you plot. But if, let's say, you've forgotten that the shape of is looking like that, what you do, you just choose some points to remind yourself. For example, x is equal to 0 and y is equal to 0. You cannot use these points because those are called asymptotes. The graph will never touch the x-axis and the y-axis. So you can choose simple points like x is equal to 1, and then when x is 1, you put your value for 1 there. Where there is x, you put a 1, and then you can see y is minus 8. Just a few points to kind of give you an idea how this graph is. So when x is 2, you see that y is minus 4, and then when x is equal to 3 won't go into 8, and then you try 4, y is minus 2, and then when x is equal to 8, y is equal to minus 1. So this can give you an idea which side it is. So if you start to sketch from this, you can actually try. Remember, they don't want you to show much of the working, they just want you to sketch. So if you're going to sketch this graph in here, it doesn't have to be, it's just a sketch. You don't have to show any numbers here. It's just a sketch. and the labeling of the graph that is important. But you can see here, if I can say when x is 1, y is negative 8. So when x is positive 1, y is in this case negative 8. So I've got somewhere here, if I say 2, 4, 6, 8. So this is my negative 8, negative 6, negative 4, negative 2, and 0. So you can see, if I can call this my 1, this is my 2, 4, 6, and 8. I'm just showing you how quickly you can do that. So when x is 1, y is negative 8. I can have my point somewhere here. And then when x is 2, y is negative 4. I have my point somewhere there. You see where the graph is. When x is 4, y is minus 2. I have my point somewhere there. When x is 8, y is negative 1. So you can see how this graph is shaping. It is shaping from this end going all the way. This is how this graph is shaping. So you have got this graph, as I said. If you look at the graph that I was referring to, this is the graph that I was referring to. So in a way, when one quadrant is that, so it's in quadrant number 4, the other graph will be in quadrant number 2, similar to the one on top. So this is the sketch that you'll be having. So that's what you have in this case for the graph. So this graph is called, they said xy was equal to minus 8. So xy is equal to negative 8. And then what's the name of the graph? It's a hyperbola. And then you get some good marks out of that. I hope you can see that. So this is how you plot this graph to say xy is equal to minus 8. And then the last graph here that is we must plot is 3,13. Says y is equal to x cubed minus 9x. Now this is 4 marks. It's the power there is 3, x cubed minus 9x. So if I do the same thing here and say, if I'm to write, so we have y is equal to x cubed minus 9x. So the important thing is the sketching here. So you need to be quickly to recognize these graphs. So in here, if I can quickly solve x cubed, not x squared, sorry about that. So I can factorize x. So I'll have x squared minus 9. I think you can see that. So which is equal to y is equal to x, which is x squared minus 3 squared. See that? And y is equal to x. So it's x minus 3 and x plus 3. So what is this? This is I can find now where the graph will cut the x-axis. So when, for example, the x-intercept, now in the x-intercept, that is where the graph will cut the x-axis. Y is equal to 0. So what I will have x minus 3, x plus 3 is equal to 0. Now I'll have the graph will cut it x is equal to 0, or x minus 3 is equal to 0, or x plus 3 is equal to 0. You can see this one goes on to become x is equal to 3, and this one goes on to become x is equal to minus 3. So this is where the graph will be cutting. So the graph will be cutting at x is equal to 0, x is equal to 3, and x is equal to minus 3. That's the first part. The second part is to find the y-intercept. So we've gotten the x-intercept, which is the first one. Now the y-intercept, remember where the graph will cut the y-axis, x is equal to 0. So if I go to the original graph and put a 0, remember it's x cubed minus 9x. So y is equal to 0 cubed minus 9, 0. It gives me a 0. So which means the coordinates there, I've got 0, 0 as the coordinates. I can actually write them with this to say these are my coordinates, 0, 0. In my coordinates here, it's 3, 0, and the other one is minus 3, 0, and the other part is 0, 0. So these are my coordinates. That is all that is important as far as plotting this graph. So I can now use that information to be able to sketch now this graph. If I can do that, what I have, I can have my lines like this. Just draw my Cartesian plane as much as I can, and then I have that here. Alright, remember this is a sketch again. Accuracy is not really important, but you need to be able to sketch that. So y, x. So now another thing that is important though is to know the general shape of this graph. So now if I can show you two separate graphs that are possible. You have this type of graph of this nature, so you have that, and then you also have the second type of the graph will be this type of a graph. Say that. So the first one, this graph, is when you are having, in this case, ax cubed, and then you will have other things following. And the other graph, this one, you'll be having minus ax cubed. I hope you can see what is happening. So when it's minus, it curves in first. When it's plus, it curves in the other way around. Just look at the difference that you're having there. So this is the shape of the graph that you'll be having. So now let's look at the points. If I'm to in a way plot these points, I have got in here 0, 0. Remember that was the point that I'm having there. It's 0, 0 from that part, and then I've got again 0, 0. I've got 3, 0. So where is my 3? So I can have here as my 3. I can actually have it there as my 3. X is equal to 3, and then on the other side I can have x is equal to minus 3. Alright, so you don't need to go deep and find the turning points of this graph and everything, but what is important is the sketch and the shape of the graph. Now because this graph, in a way, it is the positive graph, so what you have a graph that will cut through here. So you have a graph and that will cut there. Do it. Alright, so it will come and cut there. So after cutting, it comes and turns and also cut there. So this is the graph of y is equal to x cubed minus 9x, and this graph is called a cubic graph. It's cubic graph. So that is what you call the name of the graph in that. So this is the 4 marks when they say draw the graph as well as label the graph fully. So that was the part on that. So let us move on to 3.2. Says in the following sketch, AB is a tangent to the circle with its center at the origin. So if you look at this question 3.2, you've got a question here which says you've got A and B, which is a tangent. So you can see AB, it's a tangent. By the tangent meaning it is touching that particular circle there, and the point there that you are given is 4, 3. And then the center is the origin, there is the center. And then the next thing says determine the equation of the circle. You need to know the general equation of a circle here. So 3.1.2, I mean 0.2.1. Now the general equation of a circle, remember, is x squared plus y squared is equal to r squared. Right? So now you have got the points 4, 3, and then in this point 4, 3 you have got x, and you have got y. So you can substitute where there is x, which is 4 squared plus 3 squared. Remember to put the brackets, is equal to r squared. So this helps you to find the radius of the circle. So it is 4 squared plus 3 squared, and then it gives us 25. So 25 is equal to r squared. To find r, you square root both sides. So r is always positive because it's the radius, and therefore r is equal to 5. So now when the first thing is to find the radius, then after that says determine the equation of the circle, then the equation will be x squared plus y squared. Now where there is r squared, you put 5 squared. So that's the equation of the circle. Or you can say x squared plus y squared is equal to 25, because remember r squared is equal to 25 in that case. So it's up to you how you want to write it. So this is the equation of a circle, and with that you get your 2 marks. Now the next question, it says calculate the gradient of the line AB. So for us to find the gradient of that line AB, what we need to do, remember we know the point, we've got point 43, and we've got 2 points here, and in the origin you have point 0, 0. This is very, very important for you. So now the first thing is you join those 2 lines to find your radius. We said this was the radius, remember, like that. So if this is your radius, now what is the gradient of the radius? Remember, the tangent and the radius, they meet at 90 degrees. In other words, they are perpendicular, and there are 2 things you're going to do. Number 1, find in here, find m, or meaning gradient of radius of radius, meaning find the gradient of the radius. Number 2, after finding the gradient of the radius, use perpendicular to find gradient of tangent. Now you remember by perpendicular it says m1 times m2 is equal to minus 1. You can check that if the lines are perpendicular, you will know the gradient of the second line if you know the gradient of the first line. And then number 3, what you do then is use point 43, that point 43, to find equation, and how you're gonna work that, you'll use n of the equation, y is equal to mx plus c, or y minus y1 is equal to mx minus x1. Well, I prefer this one, so let's quickly do that. First one is to find the gradient of the radius. So I've got 2 points. I've got 0, 0 and 4, 3. Now let's find the gradient. Remember, gradient m of radius is y2 minus y1 over x2 minus x1. So now my y2 I can choose now. I can call this my x1, y1, my x2, y2. So now when I do that, I will have y2, which is 3 minus 0 over 4 minus 0, and the answer is 3 over 4. So now I know my gradient is 3 over 4. Now remember, we said the formula says m1 times m2 is equal to -1. Now to find, in this case, the gradient of the other one, I know my m1 there is represented by my mr. So if I say 3 over 4 times my second gradient, which is the gradient of the tangent, I'll call it my m2 there, is -1. So you can multiply by 4 over 3, multiply by 4 over 3, or divide by 3 over 4, whatever case you find. So you find the gradient of the tangent, which is equal to -4 over 3. So you see, I now know the gradient of the tangent, Now the next thing to do is to use, that is now number 2, that is step 2 here. This was step 1. Now step 3, it says I need then to use that point 43 to find the equation. So I'll use y is equal to mx plus c. Now I'm using point 43 and my y there is 3 is equal to m. Remember, I got the gradient, which is my m2 there, which is negative 4 over 3, and then my x, that is the 4 plus c. So this equation helps me to find c. So if I simplify this negative, if I take it to the other side, becomes positive. So it's 3 plus 4 over 3, 4 is equal to c. So if I do that, I will have 3 plus fraction, which is 4 over 3 times 4, and then I'll get 25 over 3. So I've got my c as 25 over 3 is equal to c. Then says determine, actually I'm moving on ahead here. The question was find the gradient of the line AB. So this is actually done. I was actually answering a question that was not asked here. The gradient of AB, you don't need now step number 3. You don't need step number 3 here, because already that is the gradient of AB. The one that I am showing you here, in a way, that is now looking at C. I'll check, maybe there is a question that is actually looking for this. Let me not erase. So you don't need number 3 here. You only need up to number 2. Says find the gradient of the line AB. So the gradient of the line AB there is equal to minus 4 over 3. That's what they wanted there. Then there is that question, actually question 3.2.3 says determine the equation of the line AB. You see, they usually ask that question, or they ask it same time in this 3.2.2. So they want you to determine the equation is 3 marks. Now to find the equation of that is now step number 3, where you use 0.43 to find the equation, and I used that y is equal to mx plus c, and you can see that I got my c. Now the equation of a line is y is equal to m. Now my m, remember, is negative 4 over 3 x, and then my c is 25 over 3. That is how what you needed to do. But if you needed to use the other equation, in this case, this is the equation. Let's say you wanted to use this one, it will still give you the same answer. This one, it says y minus y1 is equal to m x minus x1. So the point you are having again is 0.43. So this point becomes your x1, y1. So you've got y minus 3 is equal to m. Remember, the new gradient was negative 4 over 3 from the previous question, and then you've got x minus x1, which is 4 there. Don't forget, you are not using the gradient for 3. Don't use this gradient. This is no longer the gradient. This is the gradient of the radius. That's why we said m of the radius. Remember that. So you must use gradient m2, which is the answer that we got in this gradient, minus 4 over 3. Remember that. So when now I simplify that, just to see if the answers are going to match, it's y is equal to, now 3 negative will go to the other side. So, and then now I open this bracket and open that bracket. So this time this is minus 4 over 3x, and then that time, that negative times negative, it's negative 4 over 3 bracket minus 4. Now the negative 3 jumped to become a positive 3. So you've got y is equal to negative 4 over 3x. Then you can use your calculator then to simplify this part, which says negative 4 over 3, and then you've got negative 4 plus 3, and then you get 25 over 3, which is positive 25 over 3. So this is the equation which is similar to that answer. If you can compare them, you can see that this is the same thing. So guys, that is what we mean whenever we are saying determine the equation of the line AB in that case. Alright, moving on. Let us look at the next question now. This is continuing question 3.3. Says given a line segment, given that a line segment passes through points, in this case is minus 2, 2 and 7, 5. Calculate the length of the line segment. Now you need to remember we also have formulas here. I was not showing you that formula, but I can always, this is given in the formulas. If we look at, let me check if the formulas that I was using, are they in here? Yes, these are the formulas for the straight line. I used this one, y minus y1 is mx minus x1, and say it's perpendicular. You see m1 times m2 is equal to minus 1. I use that. Then you have parallel lines, but the one that I'm interested in is in distance now, which is x2 minus x1 squared plus y2 minus y1 squared. So I'm interested in this formula for that question, and the question that I'm working on is calculate the length. So remember they're saying I've got 2 points, minus 2, minus 2, and I've got also 7, 5. So I can call this one my x1, y1, and my x2 and y2, and the formula says d is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. So you just substitute and you get your answer. That's why it's just 2 marks. And then what do you have? x2, you see it's 7 minus x1, which is minus 2. You just need to be careful. Look at x2 and look at x1. So you have a negative from the formula and you have a negative on x1. So even if you just punch that with the calculator, your answer will come correct. But sometimes it's good to put that extra bracket. But even if you don't, your calculator will give you the answer. I'll show you. And then you've got y2, which is 5, minus y1, which is minus from the formula, and you've got another negative on y1, which is minus 2 again. As I said, you can put that bracket and squared. So the d there, if I now use square root of, you can see, as I said, you can do punch 7 minus, then you say negative 2, and then you square it, plus again 5 minus, then negative 2 squared. See, I'm getting square root of 130. I can go back and put those small brackets. It will still give me square root of 130. I have that and I have that. You see, I'm still getting square root of 130. This is distance, so it is whatever units that they give me. Are you getting that? Now that was the first part of this question. Not difficult, but you know, it's a good question. Actually, let me just do this. I'm looking at the second question. It's something similar again. They are saying here 3.2 determine the coordinates of the midpoint. So I'm still using my point, but now if I go back to my formula here, you see midpoint in here. This is the midpoint. So x1 plus x2, p is x1 plus x2 over 2, y1 plus y2 over 2. That is the midpoint there. So if I use that in this question, as they say, p is equal to x1 plus x2 over 2 and then you have got y1 plus y2 over 2. Are you seeing that? So you just substitute for the midpoint. My x1 is minus 2 plus 7 over 2, that is my x2, and then you've got y1, which is minus 2 plus y2, 5 over 2, and then my midpoint there is equal to, now negative 2 plus 7, it's 5 over 2, and then negative 2 plus 5 is 3 over 2. This can be your answer, or you can use it in decimal, 2,5 and 1,5. So this is that, but this answer was sufficient for you. As I said, this is something that you have to use your formulas to get that. So that is the answer in that question. Now time still allows me. Let me look at question number 4. Now if you're looking at question number 4 here, okay, so this is 11 marks, and let's look at question number 4. Question number 4 says we need to differentiate from first principles, and we are given f of x is equal to 3x squared. So now if I can have a fresh page, because it does require a little bit. So what we of space is f of x is equal to 3x squared. So if I can have it here and say f of x is equal to 3x squared. So this is that. But now just want to show you something on the formulas. You have the formula, I think, let me check on the differentiation, just to check. I think there are 2 pages of formula sheet, so that you will know. Yes, that's the one that I'm looking for. So your formula sheet will have the differentiation from first principles, and this is the differentiation from first principles here. As you can see, dy over dx is lim h approaches 0 fx plus h minus f of x over h. So that's what we're going to be using for differentiation from first principles. So if I write it here on the other side, it's f, just to write it, it says dy over dx is equal to lim h approaches 0, and then you've got f of x plus h minus f of x over h. And then what I also usually encourage students is, if they are given f of x is equal to 3x squared, you can use that quick differentiation, the rules of differentiation, to find the answer. But now if you use the rules, you're not going to get any marks. If you use the rules there, they won't give you any marks. Now if I use the rules of differentiation, it's f prime x is equal to, you write the 3, you drop down the 2, and then you've got x 2 minus 1. Remember the rules of differentiation. If you don't have, if you've forgotten, just go through my previous lessons and then you can remember that. So 3 times 2, it is 6, x 2 minus 1, which is x. So this is the answer that I'm looking at. So I use the rules here of differentiation of calculus. Now with these rules of calculus, I want to use now differentiation from first principles. Look at the question, says differentiate from first principles. So my answer though must be the same as I'm using the rules. So what do? I start with the first one. My f of x is already given there. It is in the formula. I have it. Now I need to find f of x plus h. So my f of x plus h is equal to, now is 3, where there is x, I put my x plus h. Now this is squared, but squared, what it simply means, it means I have 2 of these, x plus h. Are you seeing that? And then I've got 3. Then you open that bracket like that, and you open the bracket like that. So it's 3, don't forget 3 is multiplying everything, x times x is x squared, x times h plus xh, h times x plus xh, h times h is h squared. If I open now with 3 multiplies, actually before I can open with 3, I can add that, which is 3x squared plus 2hx or xh plus h squared. If I'm starting with the alphabetical order, I'll have hx. So then I open up with 3 there, multiply by 3, you're distributing that, which is equal to 3x squared, 3 times 2 plus 6hx, and then 3 times h plus 3h squared. So this then becomes my f of x plus h. You see that I have got the top now, f of x. Now I can do that top as I have circled there, which is my f of x plus h minus f of x that I just circled there, which will be equal to my f of x is that one, which is 3x squared plus 6hx plus 3h squared minus f of x. Remember, this is minus f of x minus 3x squared. So you're substituting where there is f of x, you are substituting that. So when I have that, you can see this falls off. So I have got 6hx plus 3h squared. Then this is equal to factorize h at this present time. Just factorize h, which is 6x plus 3h. Just factorize x in this at this present stage. Then when you have done that, if you got your formula, you are now left with the bigger part. Now you are writing now that part, which is f of x plus h minus f of x divided by h. So that's what I'm going to be writing at this time, to say f of x plus h minus f of x over h. So my f of x plus h is what I have here, which is x, 6x plus 3h. Then I divide by h. You can see that this cancels, and then I'm getting 6x plus 3h. Now you can finalize this to say, now my dy over dx, dy over dx, or my f prime, which is equal to my f prime x in this case, is equal to, remember, it's the lim h approaches 0 from the formula, f of x plus h minus f of x over h, which is this thing here. So this thing became that, which is equal to 6. Now they say h approaches 0, so it's 6x plus 3. So where there is h, you write 0, and then the final answer there is 6x. Now look at the one that we got on top here. We said the answer was 6x using the rules of calculus or differentiation, and you can see that I'm also getting 6x using differentiation from first principles. So that is how you can approach that question when they say differentiate from first principles. So that was that, 4.1. Now let us look at 4.2. It says given that f of x is that, then it says determine the gradient of the tangent to the curve at the point where x is equal to 2. You can actually work it here. We are given f of x. This one rules at the moment, just rules of calculus, differentiation. It's x cubed minus 3x squared plus 6x minus 4. So first thing is find f prime x using rules. Remember, you write the 2, you drop the exponent, which is the 3, and then you have got your x. Now in that 3 is 3 minus 1. You repeat again, minus 3. This time you drop the 2, you have got x, it's 2 minus 1, plus, now if it's only x, you just say 6 times 1, x becomes 1, and then plus 4 becomes or minus 0. That is all, because it's dy over dx, so the number 4 does not have x, so it becomes 0. So when you've done that, 2 times 3, it's 6x, 3 minus 1, it's 2, minus 3 times 2, it's 6x, 2 minus 1, which is 1 plus 6. So this is my f prime x. But now they are saying, now what is f prime x? F prime x is the gradient. That is my gradient. So f prime x is equal to my gradient. Alright, this is my gradient in terms of x. So you see, I've got my gradient in terms of x. Now they are saying determine the gradient to the tangent of the tangent to the curve at a point where x is equal to minus 2. So if now I say f prime of 2, I'm being specific now to say at that point, then I'll have 6 there. So where there is x there, I put 2 squared minus 6. I've got 2 plus 6, and then I can use the calculator to simplify that, which is 6 2 squared minus 6 2 plus 6, say that, and then this is equal to 18 in this case. So that is what we are having. So the gradient, and that says determine the gradient. So the gradient of tangent is equal to 18. So that is the answer to this question. That was 3 marks in a way. Alright, and then if we can just take this off now, the last part of this question 4.3 says determine the coordinates of the local turning point f of x, and then you're given f of x called x cubed minus x squared minus x. If I can use it maybe to work, if I can work on it from this blank screen here. So I'm given f of x. So what they need is the local turning point, and you know what they mean by turning point. By turning point, what you simply need to do is to find f prime x. In other words, you have to differentiate and then you equate it to 0. That's what it means at turning point. So at turning point, the gradient is equal to 0. So they want you to find the coordinates, meaning you have to find the x and the y values of the turning point. So it's f of x is equal to x cubed minus x squared minus x. So it flows like that, which is x cubed minus x squared minus x. So first I need to find f prime x, which is equal to, remember there is a 1, there is a 1, there is a 1. So it's 1, you drop the 3, and then you've got x, you subtract 1 from 3, then it was minus x squared minus x. So it's, I did write it right. So it's minus 1. This time you drop the 2, x, 2 minus 1, and lastly in minus 1, I said when you just see the x, you just write 1 as dy over dx, and then after that 1 times 3, it is 3x, 3 minus 1, it's squared, minus 1 times 2, it's 2x, 2 minus 1, it's 1 minus 1. So this is your f prime x. Alright, so now you've got 2 points, then you say at turning point, at TP, f prime x is equal to 0. So what we have, therefore, we have 3x squared minus 2x minus 1 is equal to 0. So it's up to you how you want to do this one. You can approach it through what we call the quadratic formula. As you can see, this is now a quadratic formula. This is your A, this is your B, and this is your C. So you've got x is equal to minus B plus or minus square root of b squared minus 4ac all over 2a. Are you getting that? So that you can have at this stage x is equal to, now it will be minus 2 in this case. Let me just use actually the top part for now. So it will be x is equal to, if I continue now, b, you can see it's minus bracket minus 2. Be careful how you have that formula. You have got minus 2 for b and you've got minus on the formula, so it's minus 2 plus or minus square root of negative 2 squared minus 4a is 3 and c is minus 1 all over 2a is 3. Then you've got x is equal to, if we have that, it's minus bracket negative 2 plus square root of, and then I've got negative 2 squared minus 4a is 3 and c is negative 1, alright, over 2 and 3. So if you say equal to, the first one, x is equal to 1, and then put the negative 1. The next one, x is equal to minus 1 over 3. So you can test that one. So x is equal to 1 or x is equal to minus 1 over 3. I can quickly test it. Remember, this is my answer, the last one, x equal to minus 1 over 3. So I would say 3 answer squared, just to test it, minus 2 answer minus 1. It must give me 0. So that is correct. So x is equal to 1 or x is equal to minus 1 over 3. So I've got the first values of x. The question was determine the coordinates of the local turning point. So by coordinates, I need to find the y values. So remember my original, you go back to the original, f of x is equal to x cubed minus x squared minus x. So the first one is when x is equal to 1. So what you do here, you are going to substitute now to say f of 1 is equal to 1 cubed minus 1 squared minus 1. So when you solve that, so it's 1 minus 1 minus 1, and the answer is negative 1 because that will cancel. So you've got that, and the coordinate there, you can write it now to say when x is 1, y is minus 1. That's the first turning point. The next one is when you write the same thing, f of x is equal to x cubed minus x squared minus x. Now at this stage we are having x is equal to negative 1 over 3. Are you seeing that? So now if you had to substitute that one, you have got f of negative 1 over 3 is equal to minus 1 over 3 cubed minus 1 over 3 squared minus 1 over 3. Are you seeing that? So when we use the calculator there, it will give us minus 1 over 3 cubed, alright, minus bracket, and then I've got negative 1 over 3, this time it's squared, and then I can minus bracket negative 1 over 3 like that. So that is cubed, squared, and just that. So it's 5 over 27. So I've got this is equal to 5 over 27. Now the coordinates I'm going to have is when x is negative 1 over 3, y is 5 over 27. So the question was, find the coordinates of the local turning points. So your final answer, therefore, you're going to have it as turning points in there. And what are the turning points? You've got x is negative 1/3, y is 5/27, and the other one is x is 1, y is -1. So this is the answer to that question that they were requiring, that is 4.3 in this case. So now with that, guys, the last question that is still outstanding, it is question 5, and this is the question on trig, and that will be the last question that I'll do in the other section. As you can see, it's out of 24 marks, so I will also bring it to you. After doing it, I will also post it to you. Remember, as we say, it is important for you to subscribe to our channel so that you can be notified every time we are doing or looking at these questions. So I'm going to post this question in a few days time, just before you guys sit for your final exams, so that you can be able to see how you could have approached this trig in a way that was going to make it more easier for you. Remember, as you practice with these questions, it makes it easier for you in a way to approach in your final exam. You can use some of these strategies that I'm using to prepare for your final exams. I hope this is of benefit to you guys, and I still emphasize, remember to share the channel. If you are interested in our textbook and the videos that comes with the textbook, you can purchase it at Takealot, and it's Mathematics N3 for the underdogs. It is found on Takealot. You can purchase it, and then after purchasing the book, you will get a code which will make us register you for our online classes in our Google Classroom. I hope this is of benefit to you. See you again in the last section of this paper. Thank you.